Okay, Mom. So this is my presentation that I gave at the conference today. I'm looking at agriculture's footprint, that is how much space it takes up on the ground once we don't have petrochemicals anymore, and the impact that will have on biodiversity. So the reason why it affects the footprint of agriculture if we don't have petrochemicals is because it takes a lot of petrochemicals to make fertilizer, and without fertilizer, agriculture takes up more space to produce the same amount of food. So we can get, and it's nitrogen fertilizer that I'm mainly talking about, so we can get nitrogen from the soil, but not in a sustainable way because we use it far more than gets replenished. And there's the potential to recycle some, but not at the moment because the way that we produce wastes at the moment, all the nitrogen goes back into the atmosphere. So really the only way to get nitrogen sustainably is to get it out of the atmosphere. And the Haber-Bosch process, as you would know, it uses huge amounts of energy because the nitrogen bond is very stable, very strong bond. So we're trying to make ammonia and compounds like that, which are much more reactive. And the other way we can do it is with biofixation, which is what organic agriculture uses. So that's things like legumes. Okay, so why is there a footprint difference? Well, at the moment, the Haber-Bosch process has a very small footprint, but it uses materials which are not renewable, and it produces large amounts of greenhouse gas emissions. But if we go to the alternatives, which are things like green manures and renewable energy, then they have got much bigger footprints. And then that competes for land with habitat and with cropland. And all of those processes take nitrogen from the stable form out of the atmosphere and put it into the biosphere in these very reactive forms, which create pollution. And that's one of the planetary boundaries, they call it. This is one of the environmental problems which they think has reached a dangerous level. There's only two so far. It's one, and biodiversity decline, which is the other thing I'm looking at. Okay, so what are the footprints? Well, I looked at the three most land efficient green manures and the three most land efficient sources of solar power. And these are the ranges of footprints that they would produce if we were to get all of our nitrogen from them. So the big green circle that you can see, that's the maximum for a zola. And these little circles that are in Australia, they're the maximum and minimum footprints for renewable energy, wind power and solar power. So between the best option and the worst option, there's a 10,000 times difference in size. So here, this map shows what would happen to agriculture if we don't replace the nitrogen fertilizer. So we need this much more land to produce our food. And the colours represent the impact that would have on biodiversity. So you can see that the impact is largely in East Asia and in Central America. And then by contrast, this map on the left shows how much impact there would be on biodiversity if we got the nitrogen and replaced the nitrogen using solar power to power the Haber-Bosch process. So it's pretty hard to see because the areas are so small. It's pretty hard to see on a global map, but the inset is zoomed into the California and Mexico border area, so you can see that there is a difference in the impact on biodiversity in different places. So it does matter where you put them. And the map on the right shows the solar power stations. So how I got these areas was I buffered the existing solar power stations. So the map on the right shows how much area we would need if we were going to get all of our energy from solar power. And there you can see very clearly that there's a difference in biodiversity impact in different parts of the world, particularly in East Asia. There's very high biodiversity impact. But the interesting thing to note about where people put solar power stations at the moment is that they're not putting them in places where most of the sun is. So there's relatively few in the tropics, and in the northern hemisphere they mostly put them in the subtropics. So that makes them less efficient for getting solar energy, which means that then we need a larger area. And I should say, that the difference between the area that we need from using solar power to get our nitrogen and just letting the cropland expand is a 2,000 times difference in land area and an 80,000 times difference in impact on biodiversity. And the reason why there's such a big difference is that the areas that you choose for solar power, which tend to be dry areas, have got about 40 times less biodiversity than the areas that the agriculture expands onto, because agriculture goes into areas which are good for life. It's good for wildlife as well as for agriculture. So I think that's pretty much it. Oh, I was just going to say this: the solar, getting all our power from solar power as opposed to just the nitrogen, is about 50 times the area. So this map on the right here is about 50 times the area of nothing, because we use about 2% of our energy to make nitrogen. That's it. Bye.